Hello everyone, welcome back to practice session. So we are back again and we are practicing the OOPS concept plus async concept, which is our end goal concept. We are practicing system design. So our main motive is to understand the system design and excel in that. So how can we are more better and understand and design a scalable system, which also helps us to increase our level and understanding about the development phase. So for now we are practicing some micro questions. So we excel that and become a hero in that domain, and then we will be proceeding some of the most creative and interesting questions and about the just let me check. Okay, yeah, the audio is clear. Yeah, we will be targeting the packages, extensions apart from just only for website, because websites and applications are quite similar and yeah, they are already popular domain. But what about the how a package has been created, how a extension has been created? These are the domains some which are I think unreleased or kind of unlisted thing. I didn't getting the word actually. Underrated. These are the things are which are underrated. So we will be exploring all the underrated content of the related to JavaScript. Yeah. So let's start today's session. And for those who are new, just giving a brief about, we are practicing the system design in JavaScript. So join us and support us, and you can also share your problems and the questions that you are practicing solving. And apart from or also in the development, we will love to see the problem statement and your help in and also contribute. So we are focusing to create a community where we all learn together and improve ourselves. So you can also share your feedback, your comments, or your questions, anything related to something that you want to share with us. You can share with us in the comment section as well as in the community section. We have in a YouTube as a community section. We will love to see. Okay, let's start our today's session. So our today's question is we have been starting some micro engines. So hero system design, you need to master stateful micro engines. Okay, these are the small self-contained classes that handles the real world backend architectural problem like resource management, load distributions, and failure recovery. Okay, got it. Here is your system design roadmap, processing from level 1 no voice to level 4 hero. Okay, so in our games we have a 4 level, level 1, level 2, level 3, level 4. Let's play it as a game and learn it from it. Okay, so here is the system design roadmap. Okay, got it. Strict object orientations. Okay, so mainly focusing on the object orientations. Yeah, oops concept. Although the JavaScript is a prototype based language, but here we have to follow the object oriented thing so that we can master the system design. So what is the first question is level 1 question is the connection pool manager. Okay, the resources management. The problem, opening a database connection takes time and memory. If the 10,000 users visit your site, opening 10,000 connection will crash your database. Instead, system use a pool of a few pre-opened connections and reuse them. Yeah, this is the real world problems that we are facing when we see a huge number of users which visits our databases. Either it can be mobile applications database or it can be the website, because you can expect whenever neat login you have a neat result paper this share or or a state board website which shares the result. So you can see sometime the website is overcrowded and it's become crash, it's going to crash, so it's happened. So like this type of situations how we can handle. Yeah, let's say this. So it's a micro questions for that reference, so we will be able to understand what are the things is going on. The problem is we have been understood. Okay, the task is to build a connection pool class. Let's start with the creating a class connection tool. Okay, we haven't created a classes and requirement a constructor. Okay, we have a constructor which has a max connections. Okay, example 3. Okay, let's have more. We have a private state, which means we have to create a private variable. This is a concept of encapsulation. If you're following us, we should know that we have been completed the OOPS concept in our past session. So if you know that about the OOPS concept and the more important the four more main pillar of the OOPS, you can mention in the comment. We will love to see that you are also growing, and with together we can make something great place. Connections equals to okay, private and the start equals to okay, max connections. Okay, which means we have to assign this dot uh, hashtag available connection connections equals to max connection. Okay, so we have inputted the value. This is available connections equals to max connections. Okay, private methods, we have the methods. Let's go with this public method. We have a async acquire connection. Okay, acquire connections here. Decrement the available connections count by one. Available connections. Okay, so this dot hashtag. Do you know what is the hashtag? Why we use this? So you can share. You can tell us in the comment section. Tell us in the comment section why we use the hashtag. Okay, so created the hashtag connections, available connections. In that, what we have to do is, let me just check. We have to decrement, which means minus equals to 1. So what is the value of, what will be the value of the available connections? So we have to just minus 1. This is the acquire connection, which means whenever user want to connect with our website and which will be directly connected to database, so there will be a certain amount of a space. So space will be deducted because a user has been acquired that space. So what is the next step? Let's say connection returns the connection acquired. Okay, which means users is uh, connected the acquired pool size x. Okay, let's just paste this here. Oh, not here, inside this. And does it pool size x? If the connection has 0, it should immediately return error. Okay, so we have to follow this thing also. Let's check how we will conditioning. If the available connection is 0, so here the connection is if let me just copy this. If this dot copy is equals to 0, available connections are, if the available connections are 0, which means we have to less than equals to, if less than equals to 0, which means there are no, because sometimes it can be minus also. If available connections less than equals to 0, it should return an error, connection system overloaded. Let's just copy this and paste here. Okay, connections error. Apart from this, return connections required the pool size x. I think so we should use here pool size, which means the available connections. Let's use this backticks here, and yeah, so this is will be the start available available connection. Okay, so we did the available connection here. So if it is, so it will be written from here. If the condition is false, then it will go down and it will be returned. Okay, so first we need to minus first of all, because there will be, okay. We have another method is the release connection. Okay, release connection. So this is not okay. Return errors. Okay, got it. Release connections. What does the connection increment the available connection count? Okay, what we have to do is this dot hashtag available connection, the private variable. We have to increase its limit. Okay, available connections plus equals to what we have to do is plus equals to 1. Okay, but never exceeds the max connections. No, but never let it exceed max connection. So we have a max connection here, right? Okay, so I think we have also maintained something like count because we don't know what is the max connection now. Increment the available variable connections count. Backup by 1. Okay, release connections. Increment the available connection count backup by 1. We have been done, but never let it exceeds max connection. The returns the connection released. Okay, what is after this? It will be released. Return connection release released. Okay, released. Okay, so apart from this, I think we have to maintain the max connection also. But what we have been informed here is private connections start equals to max connections. Private variable, okay, available connections start equals to max connection. Mm-hmm. Okay. Uh, this is confusing little bit. I think we have to private state available connections start equals to max connections. So I think so we have to do this like this. We have two different things. We have been this will be in the yeah, but before that this has this dot max connection because below we have to maintain this thing. Copy this, paste here, and here it will become this dot max connection. Okay, so like this we are maintaining the variable here as a in the constructor inside the and what we have connection release connection but never let it exceed the max connection. Never let it exist, which means max connection having a something like 10. So it should not exist if the user is immediately. Available connection is 10. Suppose system design goal prevent the resource leakage and limit concurrent loaded. Okay. So in the system design goal is prevent the resources leak and limit concurrent load. Okay. Let's just understand it. So let's just check what we have done. First, we have been build a connection pool. We have class created a connection pool class. Other than this, we have a maximum connection in the constructor, right? And created a private variable available connections done, which is equals to max connections done. Acquire connections. We have been created acquire connections. This will be decrement after the available connections. If available connection and this is the conditions we have been done. Release connection, increment the available connections, done. Count backup by 1, but never let it exceed the max connection. Okay. And returns the what we have to do is return the connection released. Mm, I think so. Here we can do is this check if this dot dash time increased. Okay, available connections. If it's greater than this dot max connection, then it should return from here only. This connection return uh, exceed limit exceed limit exceed. So what we have been doing in this problem is in this programming is create working in a small micro system design question. In this questions we have to create a connection pool like in the actually the database has a connection pool when the many of the most of the users are connecting. Suppose you have a website when you have a daily users of 1,000, but one day you have an offer like Amazon big sale or a Flipkart big sale, big days like this you have a sale. So in that case what happened because of the sales, so most of the unwanted users also explore because they want to shop and get the benefits of that deal. So what happens daily you have 1,000 so capacity of a website handler, but in during the sales it has been surprisingly you got 10,000 users, so it will overload, right? So we have to manage that overload. Like we have a real world example, so that short real world example we have been practicing the system design. So we have to design a system like this so we can manage that excessive users. Okay, so this was the short brief about. So coming down to hashtag system design, so we will love to say. Okay, so we have been created this thing completed. Let's call this thing, we have a class, let c1 equals to new connection pool. Okay, we have a new connection pool apart from this. Okay, so what we have to do is let's try with a 10,000 user visitor. For now it gets the connection pool is give a variable, okay, 10, so it will be the max connection. Okay, and let's just call uh, function which is a sync. Okay, function, a sync function run. On that run we will be doing c1 dot acquire acquire connection. Okay, in that we have been doing the acquire connection. We have to pass something now, just have to wait. Let ans equals to, instead of ans we will just start as the response equals to, there's a better word, naming conventions, not a naming convention, it's a proper naming. So if you provide a proper naming, console.log run, not run, response. So it helps to easy to understand to others developer also. We call this a run. Okay, let's just check what is if anything else is required. Connection will acquire this dot, okay, turn an arrow. Async, we creating async acquire connection. Is there need some kind of set timeout or else? I don't think so. Let's just play this thing. So we will be having a try error situation here, so we can understand better. So removing the excessive space from here. Okay, this is. Let's just check. Okay, we have a error. The private field must be declared in an enclosing class. Okay, but we have been created, right? Line number 8. Line number 8, which means here this dot private accessible minus equals to 1. Okay, what does it mean? This available, the private field available connection must be declared in the enclosing classes. We have been created enclosing classes here, right? So what's the issue is here? Mm, let's do like this. Minus 1 equals to available connection. This dot hashtag available connection. I don't know what's this happened here. We have been created, right? available connection here, and it's available connection here too. Okay, connections. Okay, this is a spelling issue. It should be connections. So it's not have a issue of here. It's just having an undeclared variable because they don't understand the available connections. Okay. Now I think so. Yeah. Everywhere I have done a mistake. Yeah, connections is not connections, connections. So let's just check. Yeah. So successfully we have been debugged. And let's just say you have a connection acquired. The pool size is 9. Okay. Let's just uh, doing if we got a multiple of 10, then what will happen? Let's just check. Uh, what I think so. How do we test this out? If we do this thing like like this, what we got is 1, 2, 3, 4, 5, 6. Okay, so the response 1, response. Okay, so right, okay, response 2, 3, 4, 5. And what we have been doing is here is uh, console.log. Mm, we can do is promise dot all, and we can paste your response response comma copy paste 1, paste 2, paste 3, paste 4, paste 5. Just try another, see what just happened. Okay, and let this equals to this console.log. Yes, and we have a pool limit size is 5. Okay, we'll just check. Is the promise pending? Okay, let's have a wait here. Error connection pool size 321. System overloaded. Okay, so yeah, like this we can do this. Mm-hmm. Mm. I think we should handle inside the function is try and catch like this. We can handle. But you can see the error report. The connections acquire pool size, connection acquire full size 2. But when it's crossed the pool size 1, then error we got available connection system overloaded. Okay, so finally we completed this micro problem statement, which is related to the system design. So we have designed a connection pool questions. We have a level 4. Uh, do we check through AI or later when we will finish all the things, then we should do? Mm, okay, for now we are let's moving forward. So we will be check at the last of our problem solving. Okay, so let's comment it down. Now let's move further. We have a new level 2 question is related for the system design is the circuit breaker fault tolerance. The problem if an external API like payment gateway goes down, okay, if an external API like payments gateway goes down, constantly hitting it with a request waste system resources and slow down your app. A circuit breaker tracks failure. If the API fails 3 times in a row, the circuit trips open and block all the requests for a cool down period without wasting the hit time hitting the broken API. Okay, we have a level 2 questions for the system design. Let's check out its detail and instructions for completing the questions. Okay. Task to create a build breaker. Okay, let's follow up the instruction. We create a class circuit breaker. Okay, create a class. It has a constructor. Construction, not construct. It's not construction. It's constructor. Okay. It has some private variable, private state, which is a concept of encapsulation. Here we have a failure count. Okay, it starts at a 0. Dot it. We have a circuit state starts with as closed, CLOSED, okay, capital closed, and we also had a last failure. So what type of system design questions you are preparing and practicing? Share those in our comment section. We will love to see, and we will be try to practice that questions too in our sessions, so that we can practice together and grow together. So this is a system design question which has a circuit breaker faulty tolerance. So yeah, let's understand how it's working. So we are creating the private state. Whenever you see the private variables, which means it's the concept of encapsulation. Okay, public method, we are having a public method, async execute. Okay, it has a API call back inside it as a parameter. Got it? After that, if the state is open, so we have to check if what is this, whenever you access the private variables or any other variables that you create inside constructor or outside the constructor. So remember, you have to use the this keyword, because the this keyword represents the class. Okay, sorry, not the class, is representing the current pointing object. Okay, let's move forward with the this dot. What is about, we have to check the circuit system if the state is open, which means state is circuit state, which is this CIR circuit state. Okay, circuit state, this dot hashtag circuit states equals to open. Okay, if the state is open, check if 5 seconds has passed using date dot now. Okay, here is the level 2 questions. We have to deal with the seconds. Okay, how we are supposed to check through this? Hmm, little bit confused here. Async execute API call. If the state is open, yeah, state is open, check if 5 seconds has passed, use date dot now. Okay, uh, how we are going to suppose the check have passed using date dot now, this dot last failure, minus this dot last failure. Okay, check if 5 seconds have passed using date dot now, minus minus this dot last failure time. Okay, we have to check with the last failure time. Let's just check. Let current time equals to new date dot now. Uh, Sorry, it's not related to new here. Date dot now. It's represent a unique data. Okay, someone is there. Sessions. Pixel. Hi, Pixel Mind. Welcome to our sessions together. Let's practice together the system designing questions. So we are practicing the system design questions here. These are the some mini micro questions related to system design. So we are here practicing the system design questions so we can grow together and discover and code better and create some scalable system designs. Okay, so let's create it. Okay, check, we have to check is If check if the 5 second has passed, uh, date dot now minus last, okay, open, then we have to check if this dot hashtag last failure time minus current time is greater or equals to 5000. Is it equals to greater than equals to 5000? Then it's supposed to, if 5 seconds have passed, then reset to closed. Okay. If it is, then we have to hashtag this dot hashtag ci. What we have to do is ci circuit state equals to closed. Okay. Done. We have done closed and attempt the call. And attempt the call. What is the call? Call is about is closed, and we have to do API call back. We have to call the API. If the 5 second has not passed immediately, what we have to do? Else, what we have to do is, if 5 second has not passed immediately, immediately short circuit and return. Short circuit. How we are going to do the short circuit? Immediately short circuit. Failure count one. Last failure time short circuit. Okay. Return. What we have to return is service. Okay. I think failure count is one or something like. Run the call API inside the try catch. If it's success, reset the failure equals to 0. Mm, Build a self-healing system that handles third-party dependency gracefully. Okay, let's just understand how this system design is working. So let's just check from start one also. Create a circuit break class, created requirement state, private state, created failure count, which is has a value of 0. Circuit starts as a closed. Okay, done. Last failure starts 0. Done. Constructor, here we don't have, I think, so constructor. Let's just comment it out. Apart from this, we have to public method execute API, which has a parameter of API call. Done. If the state is open, okay, if the state is open, then check if the 5 second has passed. Okay, using the date dot now minus. So this dot failure time minus curl time. Okay, let's just give here a bracket. So okay, it's not about this, it's about this, because maybe it can be handled little bit weirdly. So this is okay, if it is greater than equals to 5000 and pass, then then pass reset the closed, we have been done. And attempt the call, I think so, which means the API callback. If the 5 second has not passed, then else return immediately short circuit and return the service unable circuit is open. Okay, got it. So other than this, let's just understand what is the next thing we have here. mm, which is run the API call inside a try catch. Okay, let's create a try and catch here. CTC catch error. Okay, so we are having a API call. I don't think so. API call is here. Run the API call inside a try catch. Okay, if it's success, reset the failure count is 0. Okay, I think so. You have also network issue, some kind of. Uh, let's just check. Just a second. I'm checking is this network is working or not. Okay. Yeah, it's working fine, I think. Network is clear and vision also clear. We are going live perfectly. Let's move back towards our problem statement. Here we have a run the callback inside a try and catch. Okay, we have to, if it's success, then reset the failure count 0. Okay, so if it's success, then we have to do is this dot failure count equals to 0. uh, let's call this here. It has a wait kind of thing, I think so. Else it will catch the error, then throw reset the failure. If it's throw an error, okay, if it's having an error, that we will do is this dot hashtag failure count, uh, failure count increment. Okay, failure count plus plus. We will do the failure count plus plus, so it will be increase, and we have to check if uh, this dot hashtag failure count, if this dot hashtag failure count is less than equals to 3, which means less than equals to 3, then it's a set circuit state open. Okay, it is less than equals to 3, then what we have to do is this dot hashtag cir cut circuit state equals to open, and la and date dot now. Okay, hashtag last failure time equals to date dot now. Okay. Let's just see. It has to return some kind of error also, I think so. Let's just read carefully. If the state is open, check if 5 seconds passed using date dot now. The last line is, if the second has, if the 5 seconds has passed, reset the state to closed. Okay. If it's 5 second pass, minus greater than equals to, yeah, if it is passed, then we have been closed. Okay, and attempt the call. We are attempting the call. If not passed, then we will be return the service unable, circuit is open. Okay, got it. Run the callback API. We have been run the callback API side inside a try and catch. Try and catch. Okay. If it's success, reset the failure 0. If it is throw error, which means increment the failure count. If the failure count is greater than equals to 3, set state is open, and last failure time is date dot now. Okay. Apart from this, we also take a response, collect here, and return that response. Return response. Okay. If it is so, to return error. Okay, we done the system design questions. So, what was the goal of the system design? Is build a self-healing system that handles the third-party dependency gracefully. Okay, let's understand the questions again. The problem is, if an external API like payment gateway, okay, we have a payment gateway external API goes down, constantly hitting it with request, waste system resources, and slow down your app. A circuit breaker tracks failure. Okay, if the API falls 3 times in a row, the circuit trips open and blocks all the requests for cooldown period without wasting the hitting broken API. Okay, whenever we try to payment some kind of, you can say during a sale, we have a Amazon Big Billion Days or a Flipkart days. So in that, during we have payment gateway in that, like we have a Razor Pay or a Stripe. In that, many time it's happened that payment gateways goes down due to heavy load or something. Yeah, if there is a internet disconnections or some kind of a issue, so you can see there is a latency and down of a server. So there we have to not waste our system resource, because if a constantly hit, which means it will be hitting the API regularly, continuously. So it is a issue, because sometimes it needs some time for fetching the data. So we have to utilize that time and resource and save our resources rather than wasting. So what we have done is this: we have been executed API. Let's just execute and check how does our variable is working. New circuit breaker. Okay, so it does not have any constructor, so we don't have to pass anything. Okay, let's have execute this API call. Mm, For that we have to create a sync let's now to fat a function here. Okay, wait, c1 dot execute. Let's have a let ans not ans let's have a response equals to wait, and console.log that response, and we will run. Okay, so let's give a double n here. Okay, we have to pass something. Okay, let's just pass console.log check, uh, checking the program. Let's just see what just happened. So we got a error unidentified async run. Okay. Uh, let's go with the function. Okay, okay, not. Actually, is like this. I made a mistake here. Const run is also async will be here nearby a function. Okay. So created done with this, and now let's run undefined. Why we are not undefined? Okay, let's just go with the function only. Our old method way. Yeah, async, and now let's just check async function run. What's the issue here? Function is a token keyword. I didn't get it. What's async? ASYNC async. Okay, my spelling was wrong. Run. Yeah, it's a little bit confusing. Undefined. Okay, here also undefined, which means it has a something. Which is true. Is this returning something or not? So if it is else, if else is returning here, else return uh something got wrong. Okay, something is got wrong, which means we have error in here. Let's just debug what is wrong here. If status search circuit is closed, open. Okay, circuit state start with closed, right? Count is 0. Fill is okay. How we should test it? Circuit state open. Execute. If it execute, API callback. And this is a callback I want to send. Okay. Uh, 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 yeah. You can see this is the callback that I want to send inside the uh execute, right? API callback. This is the API callback. Mm. So it get here, and it will be current dot dateline. So it will execute a response and return the response. Let's just check console.log here. Console.log response inside the class. Let's just see. We are debugging. Okay, something got wrong. Wait, execute. Execute. What we are getting here? Let's just see. Console dot log API call back inside class F1 first line. Okay, this is working enormous function, right? We are getting a function. It's working, which means if it is open, so circuit states dot open, which is closed, which means that it not will not run. So okay. So as per the question, I think so we have what we have been given. A circuit breaker classes, okay. Failure content, public method, okay, done. If 5 seconds has passed, which means this dot a will be. If it is open, first of all we have to check the is open or not. If the state is open, the state is not open because by default start from its space circuit state is closed. As per the questions we have been see, the starts with as closed. Okay, so we have to do a multiple attempt. What we can do is response. Let's do small r1. Okay, so again we are using here. Okay, let's say 2, 3, and we have 4. Now we are using promise promise dot all, and here we have a array. In that we have a res1 comma res2 comma res3 and res4. Okay, and we are here let this equals to here. You have to wait because this is a promise. After that it will be working. Okay, console.log res. Now we can say is let's just say error. Okay, argument line number 84. We have a 84 line number. Okay. Okay, okay, got it. We have to close also, right? So forgot to close. This was just one here. And now let's run. Anonymous function, something got wrong, something got wrong, something got wrong. Error, we are getting an error. Why? Why? Because after 3 seconds, let's try again. Let's try again. Okay, this is the issue because I think so it's opened. It's never opened. Uh, hmm, this is the correct, but the problem is because it's open. If it's never open, then how we are supposed to do? Mm, okay. I think so. We have to start with the constructor. Constructor, and in that constructor is having a state. In this state, we will be this dot hashtag CIR circuit state. We are just modifying the thing because we want to start, right? The state is, and now let's just check if its state is working or not. So here pass the open. Let's just check now. Something got wrong again. Circuit breaker state as passed, and we will able to see this. Okay, just check. Open. Okay, it goes inside this, and now the circuit state is open, right? After open also it's not running. What's the issue with this now? And I was class one, something got wrong we are getting. But it should not be something got wrong. Mm-hmm. Mm-hmm. Mm, what is something wrong opened here? Okay. Date dot now. Let's just see. So what log current time. Mm, okay. Sorry. It's not opened. It's open. That's why it's not. Uh, now service enable. Circuit is open. Circuit is open. Circuit is open. Oh, service enable. Okay, so we successfully debug something, but we have to see how it's working because we want the checking the program result. Mm-hmm. So let's just comment this out first of all. Console.log here and console.log here. I check the circuit is unable to open. Okay, let's little comment this out, uh, and now we remove this thing. So service is unable to open. Okay, uh, let's just comment all the thing, and instead of this let's just console.log res1, so we will be able to see. Okay, so again the service enable circuit is open. Let's just check what is happening here. Let's just current the time, comma, this dot hashtag last failure time. So we have a 0. If minus, then it should be greater than equals to 5000. Then service is closed. Report. Also, we want to see this thing. It's minus. Why it's minus? Oh, is this? Let's just reverse the thing because whenever it's a minus, it shows a wrong timing. So because of the negative value, it was showing this. Checking the program undefined. Okay, so finally we completed this. Apart from this, we want to check other thing also. Let's just check it. Closed inside here. These are the debugs we have been using here. Okay, now it's finally working fine. Just want to check with, first of all, this checking why it is undefined because we are console.res something. Uh, just call the res one, not res one. Okay, let's remove this and see here. Checking the program. Okay, it's working. If we do this thing at rest, and after that what we do is here uncomment this whole thing and just see, await all. Okay, checking the program, but after the 4 also, because I think so. Is it greater than 5 seconds? Okay, it's about a greater than 5 seconds. It's a return error. So return service is unable. If it's closed, then service is unable. Okay. Mm, mhm. And it's never going to last time, right? Because failure is catch error. Mm, what do you think? How does it work here? Let's revisit the question itself. We will get a clue from there. Run the API call inside a try catch. Okay, done. Inside the try catch, we have been run, and if it succeed, so it's succeeding only, right? If this is greater than equals to 5,000. Uh, it will be, and it will be always be 5,000, right? Reset the failure equals to 0. Done. Mm, yeah, I think we are satisfied, but I want to see a fail condition also there. But I can't able to see. If you are noticing something, let me know in the comment section. Close the attempt if the 5 second has not passed. Uh, 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 uh. I don't know. I'm a little bit confused about it. Okay, I think so. This is but it has a test case wrong. Let's take the help of AI, and we have been completed this two solutions: the connection pool manager, and partially completed the circuit breaker also. Let's just understand the solutions review by the AI. So let's give them. We have completed the first two level questions. Here's the solution. Here the solution. Check them and uh, review it, and give feedback. So let's just check by the AI how it's working. Okay. You are making fantastic progress shifting into low level software engineering. You are thinking about the real back-end vulnerabilities like system crash and threat limits. Okay, let's do a strict engineering review of the both architecture. Both models contain critical logical flaws. Okay, in the both of the system designing for your solutions, it has a flaw something. The bug found is less than minus equals to 1 in this. Okay, so first was the pool connections. So we have to handle the pool connection if the user is unexpectedly double or increasingly sarcastically it has been increased, so we have to manage the overloaded crowd. So here we have the pool connection problem. So the negative index guard leak, look closely at your allocation condition. Okay, what was the allocation condition? Acquire, we have done is this dot available connection minus equals to 1. Okay, if the allocation collection is less than equals to 0, return error. If your maximum pull capacity is 5 and you are call it 6 times sequentially, then count decrements before the check. Okay, on the fifth call the count becomes 0, triggering the error string, means the fifth connection is completely blocked. Okay, understood. Error string, which means so unfortunately we've given it should be inside the thing. Okay, or what we can do is rather than inside it we can just do this like this. After that, if it is not returning, which will be it has the available connection, then it will be minus, and return the guard bypass release connection. And the release connection also we have some issue and flaws. Let's check, which is if available connections is greater than max connection, because your increment after this line. Okay, the count can grow infinitely without even hitting the guard statement. Okay, so what we have to do is here we have to do the up. Okay, so yeah, so let's check the solution with this max connections. Okay, correct. First we have to check, after that yeah we can see now the same is the we have been done. And releases connection is first check. Okay, prevent full. Okay, it's a little bit different. If the available connections greater than equals to max connections, okay, we have to check the equal to max connections, then return the limit exceeded. Okay, so you were right actually. So we just want to equals to check. Okay, limit exceeded, and other than this, apart from this, all is good. Okay, these elements, the ghost state bypass the entire execute logic. Okay, so okay. So we have been such minor flaws in our first question. And in second questions, we have this dot circuit is open. Okay. The coast state bypass, your entire execute logic is wrapped inside an if this dot open condition. If a circuit is breaker and as the initial is closed, the standard operations mode, your method ignores the fallback entirely. Yes, because we face this. Skip the callback execution and return something got wrong. We are facing this something got wrong in starting only. The construction injection vulnerability. A circuit breaker shouldn't rely on a user manual passing an open or close string. Okay. We restructure the method into an operational router. In intercept request, okay, it should like this. First is zero closed. Okay, good. API callback. If this dot circuit is open, date dot now current minus last 5000 not equals to current time minus this dot last time is less than 5000. Okay, we just got some up and down. Okay. The try and const will be not inside the if else. This is if else condition is okay. Execution phase is try and catch. Okay, so here the what all the things is happening. We didn't get any solution because we are trying to try and catch inside the if else. That was our biggest flaw. Okay, let's fix this. If it is less than 5000, then what should it do? Let's create. Okay, so actually we haven't deal with this, but we it was services unable, which this line, which was in the else statement. But let's return from here only. Okay, and this dot circuit state is half opened. Okay, we have a half opened. I didn't know about this. Okay, let's just follow half open and okay, let's close this for now. So this was the thing initially it was doing, and here we are back again. So just want to this thing. So now we have a try catch, right? Try and catch here. Anything other than that we have. Okay. Return something got wrong. We don't have to check now. Return something got not wrong. We are just checking the try and catch. And now we can see execution phase, which is const result await callback. This dot zero, and here we have to this dot. Once it is executed, the answer it circuit state should be closed. Okay, understood. And return the result. Okay, this is the good thing. And what about the catch thing? Failure plus equals to plus plus, which means plus equals to 1. Last dot failure equals to date dot now. Okay, we are doing this also in the if statement. Yes, these are the flaws. We have to practice more and more about this to understand and betterment. So we'll be doing it in our sessions. You can join us and practice together so you can understand also betterly what we are doing. So date dot now apart from this is greater than open. Okay, this is fine and return the execution failed. Okay, this is a more creative. Can do this like this execution failed. Okay, let's do with backticks only. Uh, okay, let's create this. And now I think so it's working. Load balancer. We didn't completed with this. I think so this is the question. Yeah, this is the level 3 questions that we will be doing in the next session. For now, we are just digesting these things. We have been practiced. Yep, let's just run. C1 is not identified, has been declared. Okay. C1 is a circuit breaker open. Okay, we didn't also done the constructor, right? We didn't want to do this thing also. Uh, let's just remove this. Uh, C1 identify has been declared. Where is the C1 even declared? Okay, let's see. Okay, let's just change a little bit. This is a circuit breaker, and this is the C2, C3. Let's be a C3. Okay, let's comment it out first of all, so we can see the last questions output clearly. Checking the program, yeah, all is working fine. And what we do if response dot 4, then what we see, checking fine. Let's put one more. So 5. If response dot 5, then what is it about? Checking fine. So one is the break statement. A little bit confused now also. Yeah, apart from this, I understood. Let's just ask AI only. So what are the test cases result of the error of the failing system? I want to see the error handling. And test case here. Okay, let's just check. What is the error handling test case here? Failing harnesses. Okay. Mm-mm-mm. Okay, let's just copy this out, whole things, because it's too much thing. And let's just understand how it's working here. Mm, mm-hmm. Mm, okay. Actually, all the test cases are like this. You just have a glimpse of the thing. What we have done is here, created a, okay, this was a mock failing API. So we created a customized custom and promise which is failing. You can see the mock failing API and created a wait which is a set timeout, which means for the delaying for actual visibility how the server is working. So create a function failure suit. Inside that we have been called the classes, and inside that we have execute the c1 dot execute mock failing API. Okay, so they passing this mock failing API. This is a callback that is passed, API callback. Okay. Got it. Oh, understood. Okay, like this they are working. Also, they have been working with the await. This is a asynchronous thing. They have been tried to create a artificial latency using the asynchronous JavaScript. Okay, got it. Like this, how it's doing. So these are the practice sessions of the system designing, and we hope you enjoyed our today's practice sessions, and you are also practicing. So join us and practice more with us related to system design questions in JavaScript, so we can develop the more efficiently a scalable system design the softwares and the whatever we have been creating. So we will love to see your comments and your feedbacks. Apart from this, also if you have some questions related to development or some kind of programs, you can share with us, so we can also practice on that and together we grow togetherly. You can also join a community where we are practicing together and sharing the details. In YouTube, you have a community. We will love to see your post and question problems. we can solve in the live session together. Join us and subscribe so you will stay updated. That's it for our today's session. Okay, someone has commented, Hussein Marfouk. Okay, sorry, pardon me if I wrong pronounce. Yeah, hi Hussein. Will you review my portfolio? Yeah, we will love to see that, Hussein. You can share that thing in our community section. Share your portfolio in the community. We will love to see, and our community members and people also can see your portfolio and access it. Okay, that's it from my side. We will love to see your portfolio. Meet you in the next sessions. Till then, good night. Bye, Gagan.